Okay, finally our last problem. I'll give you a second to read it. All right, so what we see is we have the area underneath this curve, x squared plus 3. The curve is drawn over here, x squared plus 3. We have a little visual. The x-axis, so it's bounded below by the x-axis. And on the left, it's bounded by x equals 1. The question is, how far do I have to go to the right to make sure that the area under this whole curve is 12? I encourage you to pause the video and try to write that symbolically with calculus using that integral symbol on your own first, and then press play and check it. I'm going to go right now and show you. Okay, so that is the integral from -1 to a. We want to find a. We don't know what it is. Of that function, x squared plus 3 dx. But we do know what we want the answer to be. We want the answer to be 12. There's a really crafty way to do this in your calculator. So I want you to go to your calculator and open up a graph page. You're going to go to the same thing that we just used, the button beside the 9 and the same blue thing that you see here on the right-hand side. I'm going to say the integral from -1 to x, because this is a function in terms of x and not a, but we know in the problem it was an a, of x cubed plus 3, x squared plus 3 plus 3, dx. Cool. That's the area under that curve for different values of x. So from like -1 to -1, -1 to -1, the area would be 0. That makes sense. There's no area if I could just go from -1 to -1. From -1 to 0, I could say trace, graph trace. -1 to 0, the area under the curve would be 3.33. Interesting. What about menu trace, graph trace? Let's go the area from -1 to 2. I'm going to press 2, enter. Oh, that's the answer. It's 12. I didn't mean to do that. Okay, well, the answer is 12. The area is 12. But it worked out nicely. But if I didn't do that, you don't really want to guess and check, you can graph another line, tab, at 12 and see what does that upper bound need to be? What does this upper bound x on this blue curve need to be so that the answer is 12? And if you find that intersection there, menu, analyze graph, intersection, you'll see that it should be when x equals 2. So in our problem, it would be when a equals 2. So pretty cool how we could use technology to do that. We'll learn more about how to do this without technology later, but right now we just want to get some ideas across about what this symbol means and how to use technology with it. We'll do the algebra part soon.